Welcome to today's episode on compounds of nitrogen, in which we study mainly ammonia and nitric acid. Let us first begin with ammonia. Children, ammonia is present in small quantities in air. It is formed in soil by the decay of nitrogenous organic matter, that is urea. Urea reacts with water to form ammonium carbonate, which decomposes into ammonia, water and carbon dioxide. We will next learn about preparation of ammonia. Ammonia is prepared by heating ammonium salts with a strong base.
On a small scale, ammonia is prepared by heating ammonium salts with a strong base like sodium hydroxide. Ammonia is also prepared by treating ammonium chloride with potassium hydroxide. The products formed are ammonia, water, and potassium chloride. In the laboratory, ammonia is prepared by heating a mixture of slaked lime and ammonium chloride. The products formed are ammonia, water, and calcium chloride. Let us now learn about formation of ammonia by the action of water on metal nitrides. Magnesium nitride reacts with water to form magnesium hydroxide and ammonia. Aluminum nitride reacts with water to form aluminum hydroxide and ammonia.
Children, let us now learn about manufacture of ammonia. On a commercial scale, it is manufactured by Haber's process. This reaction is reversible, exothermic, and occurs with decrease in volume. Therefore, according to Le Chatelier's principle, the favorable conditions for the manufacture of ammonia are low temperature, high pressure, catalyst. Let us discuss them one by one. Low temperature. Since the forward reaction is exothermic, low temperature will favor the formation of ammonia. However, at low temperatures, the rate of the reaction will be slow. The optimum temperature for the reaction has been found to be around 700 Kelvin. Let us now discuss about high pressure. Since the forward reaction occurs with decrease in volume, high pressure will favor the formation of ammonia. The reaction is usually carried out at a pressure of about 200 into 10 raised to the power of 5 pascals or 200 atmospheres. We will now discuss about the role of catalyst. The rate of reaction is fairly low, around 700 Kelvin. It is increased by using iron oxide as catalyst with small amounts of potassium oxide and aluminium oxide. Sometimes molybdenum is used as a promoter, which increases the efficiency of the catalyst.
Children, let us have a look at the flowchart for the production of ammonia as shown on the screen. Nitrogen from air is allowed to mix with hydrogen obtained from natural gases. The mixture of gases is compressed with about 300 atmospheres and heated to about 450 degrees centigrade. The gaseous mixture is then passed over a catalyst, which in this case is iron. Some ammonia is formed. About 10% of the mixture of gases leaving the catalyst chamber is ammonia. When mixture is cooled, ammonia turns into a liquid. The unreacted gases, nitrogen and hydrogen, are recycled. Liquid ammonia is collected.
Children, let us now learn about Drying of ammonia gas. ਅਮੋਨੀਆ ਦੇ ਵਿੱਚ ਮੌਜੂਦ ਮੋਇਸਚਰ ਨੂੰ ਕੈਲਸ਼ੀਅਮ ਆਕਸਾਈਡ ਜਾਂ ਕੁਇਕ ਲਾਈਮ ਦੇ ਟਾਵਰ ਰਾਹੀਂ ਲੰਘਾ ਕੇ ਰਿਮੂਵ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਇਸ ਨੂੰ ਕਨਸੈਂਟਰੇਟਿਡ ਸਲਫਿਊਰਿਕ ਐਸਿਡ ਦੇ ਨਾਲ ਡਰਾਈ ਨਹੀਂ ਕੀਤਾ ਜਾ ਸਕਦਾ ਕਿਉਂਕਿ ਇਹ ਸਲਫਿਊਰਿਕ ਐਸਿਡ ਨਾਲ ਰਿਐਕਟ ਕਰਕੇ ਅਮੋਨੀਅਮ ਸਲਫੇਟ ਬਣਾਉਂਦਾ ਹੈ। It cannot be dried by passing through anhydrous calcium chloride since it forms a complex having the composition CaCl2.8NH3. It cannot be dried by passing through phosphorus pentoxide since it reacts to form ammonium phosphate. Children, let us now learn about physical properties of ammonia. Ammonia is a colorless gas with a characteristic pungent smell called the ammoniacal smell. It causes tears in the eyes. It is heavier than air. Its density is 0.68 grams per cubic centimeter. It is extremely soluble in water. 1 volume of water can dissolve about 1000 volumes of the gas at 273 Kelvin. Ammonia can be easily liquefied by cooling under pressure. Liquid ammonia boils at 239.6 Kelvin and freezes at 198.4 Kelvin. When vaporized, liquid ammonia causes intense cooling.
Let us now learn about structure of ammonia. अमोनिया विच नाइट्रोजन एटम sp3 हाइब्रिडाइज्ड है। 4 sp3 ऑर्बिटल्स विचों 3 ऑर्बिटल्स 3 NH सिग्मा बॉन्ड्स बनाਉਂਦੀਆਂ ਹਨ ਜਦੋਂ ਕਿ 4th हाइब्रिड ऑर्बिटल contains a lone pair of electrons. क्योंकि lone pair bond pair repulsions ਤੋਂ stronger है जिस करके HNH bond angle decreases from 109 degree 28 minutes to 107 degree 8 minutes. नतीजे वजों ammonia molecule has pyramidal geometry with NH bond length of 101.7 picometer and bond angle of 107.8 degrees.
We will now learn about chemical properties of ammonia. Basic nature. Ammonia is highly soluble in water. Its aqueous solution is weakly basic. Due to the formation of hydroxide ions. Being basic, it turns moist red litmus blue and neutralizes acids in the dry state as well as in aqueous solutions, forming their corresponding salts. This means that ammonia reacts with hydrochloric acid to form ammonium chloride. Ammonium hydroxide also reacts with sulfuric acid to form ammonium sulfate and water. Children, let us now learn about reaction with heavy metal salt solutions. Ammonium hydroxide reacts with many metallic salts and precipitates them as hydroxides.
Let us take an example. Ferric chloride reacts with ammonium hydroxide to form ferric hydroxide and ammonium chloride. Ammonium hydroxide also reacts with ammonium chloride to form aluminium hydroxide and ammonium chloride. In a similar way, ammonium hydroxide reacts with chromium chloride to form chromium hydroxide and ammonium chloride.
Children, let me tell you that this property is made use of in precipitating these metals as their hydroxides in the group 3 of qualitative analysis. Ammonia acts as a Lewis base. Due to the presence of a lone pair of electrons on the nitrogen atom, ammonia acts as a Lewis base. Consequently, it can easily donate its electron pair to form coordinate bond with electron deficient molecules such as BF3 or transition metal cations having vacant d orbitals to form complexes.
For example, ammonia reacts with boron trifluoride to form a complex H3NBF3 as shown on the screen. Silver ions react with ammonia to form silver-amine complex. Cupric ions react with ammonia to form copper-amine complex. Similarly, cadmium ions react with ammonia to form cadmium ion complex. Due to the formation of complex ions, white precipitate of silver chloride dissolves in excess of ammonia to form a complex compound AgNH3 whole twice Cl, that is diamine silver 1 chloride. Similarly, copper sulfate dissolves in excess of ammonia to form soluble deep blue colored complex tetraamine copper 2 sulfate. These reactions are used as tests for these cations in qualitative analysis. Let us now learn about oxidation of ammonia. Ammonia is oxidized to nitrogen when passed through a solution of calcium hypochlorite, that is bleaching powder. Calcium chloride and water are also formed. Ammonia is oxidized to nitrogen when passed through a solution of bromine water. Ammonium bromide is also formed. Ammonia is also oxidized to copper when heated over copper oxide. Water and nitrogen are also formed. When ammonia mixed with excess of air is passed over red-hot platinum gauze at 1100 Kelvin, it is oxidized to nitric oxide. This reaction forms the basis for manufacture of nitric acid by Ostwald's process. Let us now learn about action of halogens. Halogens react with ammonia in many ways. Let us learn about its action. With excess ammonia, chlorine reacts with excess of ammonia to form ammonium chloride and nitrogen. With excess chlorine, ammonia reacts with excess of chlorine to form nitrogen trichloride. Reaction of ammonia with bromine. Ammonia reacts with bromine to form ammonium bromide and nitrogen. Reaction of ammonia with iodine. Ammonia reacts with iodine to form nitrogen iodide ammoniate, which is a precipitate of brown color, and hydrogen iodide. With ammonia Ni3 when NH3Ni3, that is nitrogen triiodide ammoniate, in the dry state is either rubbed or struck against a surface, it explodes with noise, liberating vapors of iodine. Thus, it is a mild and harmless explosive.
Children, let us now learn about reaction of ammonia with carbon dioxide.
When gaseous carbon dioxide is reacted with liquid ammonia at 453 to 473 Kelvin under a pressure of 220 atmospheres, it first forms ammonium carbamate, which subsequently decomposes to give urea. Urea is widely used as a fertilizer since it slowly decomposes in moisture present in soil to give ammonia and carbon dioxide. It has very high nitrogen content, around 46.66%. Action of metals on ammonia. Ammonia, when passed over molten sodium metal at 575 Kelvin, forms soda amide with the liberation of dihydrogen. Ammonia, when passed over molten sodium or potassium metal at 575 Kelvin forms corresponding amides with the liberation of dihydrogen. Let us have a look at reaction with Nessler's reagent. With Nessler's reagent, which is an alkaline solution of K2HgI4, ammonia or ammonium salts give a brown precipitate due to the formation of iodide of Milan's base. Let us now learn about reaction with sodium hypochlorite. When a large excess of aqueous ammonia is treated with sodium hypochlorite in presence of glue or gelatin, it gets oxidized to hydrazine, sodium chloride and water. Actually, the reaction proceeds in two steps. Let us have a look at them one by one. Ammonia reacts with sodium hypochlorite to form sodium hydroxide and chloramine. This is a fast reaction. Chloramine reacts with ammonia to form hydrazine and ammonium chloride, which is a slow reaction. Glue or gelatin catalyzes this slow reaction and prevents the oxidation of hydrazine to nitrogen.
Children, let us now learn about nitric acid or HNO₂. Nitrogen forms three oxo acids such as hyponitrous acid, nitrous acid and nitric acid. Their structures are as shown on the screen. Among the structures which we saw just now, nitric acid is the most important. We will now learn about preparation of nitric acid. In the laboratory, nitric acid is prepared by heating potassium nitrate or sodium nitrate and concentrated sulfuric acid in a glass retort. On commercial scale, it is mainly prepared by Ostwald's process. This method is based upon the catalytic oxidation of ammonia by atmospheric oxygen.
Ammonia reacts with oxygen in presence of platinum and rhodium gauze catalyst at 500 Kelvin and 9 bar atmospheric pressure to form nitric oxide and water. Nitric oxide thus formed readily combines with oxygen to give nitrogen dioxide. Nitrogen dioxide thus formed dissolves in water to form nitric acid and nitric oxide.
The nitric oxide thus formed is recycled and the aqueous nitric acid is concentrated by distillation to give 68% nitric acid by mass. Further, concentration to 98% can be achieved by dehydration with concentrated sulfuric acid.
Let us now learn about structure of nitric acid. Spectroscopic studies have shown that in the gaseous state, nitric acid exists as a planar molecule having the structure shown on the screen. The structure of nitric acid is, in fact, a resonance hybrid of the two structures shown on screen. Like nitric acid, nitrate ion also has planar structure. The nitrogen atom is sp2 hybridized and hence O-N-O bond angle is 120 degree as shown on screen. In fact, nitrate ion is a resonance hybrid of the three resonance structures shown on screen. As a result of resonance, all the three NO bond lengths in nitrate ion are equal and are 218 picometer long.
Physical properties of nitric acid. Pure nitric acid is a colorless fuming liquid with pungent odor. Impure nitric acid is yellow due to the presence of dissolved oxides of nitrogen. Pure nitric acid freezes at 231.4 Kelvin and boils at 355.6 Kelvin. Laboratory grade nitric acid is a constant boiling mixture, that is azeotrope containing 68% nitric acid and 32% water by mass. It has a specific gravity of 1.504. Fuming nitric acid is pure nitric acid containing oxides of nitrogen dissolved in it. Let us now learn about chemical properties of nitric acid. Let us first discuss about decomposition.
Nitric acid decomposes on heating, giving nitrogen dioxide, oxygen and water. Acidic nature. Nitric acid is a strong monobasic acid. In aqueous solution, it ionizes as shown on screen. Being a monobasic acid, it reacts with metallic oxides, hydroxides, carbonates and bicarbonates, giving only one series of salts called nitrates. Calcium oxide reacts with nitric acid to form calcium nitrate and water. Sodium bicarbonate reacts with nitric acid to form sodium nitrate, carbon dioxide and water. Sodium carbonate reacts with nitric acid to form sodium nitrate, carbon dioxide and water. Oxidizing agent. Nitric acid is a very strong oxidizing agent since it readily gives nascent oxygen both in the concentrated as well as in the dilute form. Therefore, nitric acid oxidizes many non-metals and compounds.
Oxidation of non-metals. Dilute nitric acid non-metals नाल किरिया नहीं करता, पर concentrated nitric acid oxidizes many non-metals जिवें कि कार्बन, सल्फर, आयोडीन ਅਤੇ ਮੈਟਲੋਇਡਸ ਜਿਵੇਂ ਕਿ ਆਰਸੈਨਿਕ, ਐਂਟੀਮਨੀ ਆਦਿ ਨੂੰ ਉਹਨਾਂ ਦੇ ਕੋਰਸਪੋਂਡਿੰਗ ਆਕਸੀ ਐਸਿਡਸ ਬਦਲ ਦਿੰਦਾ ਹੈ, ਜਦੋਂ ਕਿ ਨਾਈਟ੍ਰਿਕ ਐਸਿਡ ਆਪਣੇ ਆਪ ਨਾਈਟ੍ਰੋਜਨ ਡਾਈਆਕਸਾਈਡ ਵਿੱਚ ਬਦਲ ਜਾਂਦਾ ਹੈ. For example,
carbon is oxidized to carbonic acid, that is H2CO3. Sulfur is oxidized to sulfuric acid, that is H2SO4. Iodine is oxidized to iodic acid, that is HiO3. Phosphorus is oxidized to phosphoric acid, that is H3PO4. Arsenic is oxidized to arsenic acid, that is H3ASO4. Oxidation of compounds. Dilute as well as concentrated nitric acid oxidizes a number of compounds. For example, hydrogen sulfide is oxidized to sulfur on reaction with concentrated nitric acid. Sulfur dioxide is oxidized to sulfuric acid with concentrated nitric acid. Sulfur dioxide is oxidized to sulfuric acid with dilute nitric acid. Ferrous sulfate is oxidized to ferric sulfate.
Children, let us now learn about action on metals. With the exception of noble metals like gold and platinum, nitric acid attacks all metals, forming a variety of products. On the basis of reactivity, metals have been divided into three categories. Reaction with metals like sodium, potassium, calcium, magnesium, aluminium, manganese, zinc, chromium, cadmium, iron, cobalt, nickel, tin, lead, antimony, which are more electropositive than hydrogen. In this case, nascent hydrogen is liberated, which further reduces nitric acid, giving a variety of reduction products such as nitrogen dioxide, nitric oxide, ammonia, ammonium nitrate and nitrous oxide.
Metal reacts with nitric acid to form metal nitrate and nascent hydrogen. Nitric acid reacts with nascent hydrogen to form reduction product and water. Liberated nascent hydrogen further reduces nitric acid to give various reduction products like nitrogen dioxide, nitric oxide, ammonia, ammonium nitrate and nitrous oxide. The stage to which the reduction actually occurs, however, depends upon nature of the metal, concentration of the acid and temperature. In general, more the dilution, greater is the extent of reduction. For example, very dilute nitric acid. Magnesium and manganese are the only metals which produce hydrogen with very dilute, that is 1 to 2% nitric acid. Cold dilute nitric acid. More reactive metals like magnesium, zinc, tin and iron react with cold dilute nitric acid to form ammonium nitrate. Zinc reacts with nitric acid to form zinc nitrate and nascent hydrogen. Nitric acid reacts with nascent hydrogen to form ammonia and water. Ammonia reacts with nitric acid to form ammonium nitrate. Overall reaction can be written as zinc reacts with nitric acid to form zinc nitrate, water and ammonium nitrate. With hot dilute nitric acid. With hot dilute nitric acid, ammonium nitrate thus formed undergoes decomposition to form nitrous oxide. With concentrated nitric acid. With concentrated nitric acid, metals like zinc form nitrogen dioxide. Zinc reacts with nitric acid to form zinc nitrate and nascent hydrogen. Overall reaction shows that zinc reacts with nitric acid to form zinc nitrate, water and nitrogen dioxide. Children, there is an exception. Tin reacts with concentrated nitric acid to form metastannic acid, that is HNO₂ and nitrogen dioxide.
Children, let us now discuss about passivity. ਜਦੋਂ ਧਾਤਾਂ ਜਿਵੇਂ ਕਿ ਆਇਰਨ, ਕ੍ਰੋਮੀਅਮ, ਨਿਕਲ ਅਤੇ ਐਲੂਮੀਨੀਅਮ ਨੂੰ concentrated nitric acid ਵਿੱਚ ਡਿਪ ਕੀਤਾ ਜਾਂਦਾ ਹੈ ਤਾਂ ਇਹ ਆਪਣੀ normal activity lose ਕਰ ਦਿੰਦੀਆਂ ਹਨ ਅਤੇ ਪੈਸਿਵ ਹੋ ਜਾਂਦੀਆਂ ਹਨ। ਇਹਨਾਂ ਮੈਟਲਸ ਦੀ ਪੈਸਿਵਿਟੀ ਮੈਟਲ ਦੇ ਸਰਫੇਸ ਉੱਤੇ ਮੈਟਲ ਆਕਸਾਈਡ ਦੀ ਇੱਕ ਥਿਨ ਪ੍ਰੋਟੈਕਟਿਵ ਲੇਅਰ ਦੇ ਬਣਨ ਕਾਰਨ ਹੈ ਜਿਹੜੀ ਕਿ ਫਰਦਰ ਐਕਸ਼ਨ ਨੂੰ ਪ੍ਰੀਵੈਂਟ ਕਰਦੀ ਹੈ। ਫॉर एग्जांपल, in case of iron, a protective layer of ferroferric oxide or FeO, Fe2O3 or Fe3O4 is formed on the surface of iron. Reaction with metals which are less electropositive than hydrogen. Metals less electropositive than hydrogen are copper, silver, mercury, etc.
In this case, hydrogen is not liberated. Instead, nitric acid oxidizes these metals to their respective oxides, while it itself is reduced to form either brown fumes of NO2 or colorless vapors of NO. The metal oxide thus formed reacts further with excess of nitric acid to form the corresponding metal nitrate and water. For example, copper reacts with nitric acid to form cupric nitrate, water and nitrogen dioxide. With dilute nitric acid, nitric oxide is evolved.
Reaction with noble metals. Noble metals ਜਿਵੇਂ ਕਿ gold ਅਤੇ platinum concentrated nitric acid ਨਾਲ ਕਿਰਿਆ ਨਹੀਂ ਕਰਦੀਆਂ, ਪਰ ਇਹ metals aqua regia ਵਿੱਚ dissolve ਹੋ ਜਾਂਦੀਆਂ ਹਨ ਅਤੇ ਆਪਣੇ ਆਪਣੇ chlorides ਬਣਾਉਂਦੀਆਂ ਹਨ। ਮੈਂ ਤੁਹਾਨੂੰ ਯਾਦ ਕਰਾ ਦਿਆਂ ਕਿ aqua regia 3 ਹਿੱਸੇ concentrated hydrochloric acid ਅਤੇ ਇੱਕ ਹਿੱਸਾ concentrated nitric acid ਦੇ ਮਿਲਣ ਨਾਲ ਬਣਦਾ ਹੈ।
HCl first reacts with nitric acid to produce nascent chlorine, water and nitrosyl chloride. Nascent chlorine then reacts with noble metal gold forming auric chloride. Auric chloride subsequently dissolves in excess of hydrochloric acid forming their orochloric acid, which is a soluble complex.
Children, today we learnt about compounds of nitrogen. I hope you enjoyed the lesson as much as I did. See you in your next episode. Till then, bye-bye.